All right, so I wanted to take a minute and review the problem that we discussed. This is problem number 27 and 29 for 6.1, which is talking about discrete random variables. So these are two multiple choice questions that you guys had for homework. So 27 was saying, find the expected value for the number of cars in a randomly selected American household. And we have talked about that in order to find the expected value, well, that's simply the sum of each individual value weighted by the probability of that value happening. So the probability that a typical American household or American household has 0 cars, well, that's 9 in 100 or 0.09 times 0 plus having 1 car, the probability of that is 0.36 plus the probability of having 2 cars is 0.35, and the probability of having 3 cars, well, that's 0.13. The probability of having 4 cars is 0.05 or 5 in 100. And then finally, the probability of having 5 cars, well, that's 0.02. And we would take all those and we would add them together, and we would get 1.75 for the expected number of cars in an American household. So that's the average number of cars, or the if we expected number of cars for an American household based on this probability data. So the question came up is about what percentage of households have a number of cars within 2 standard deviations of the mean. And the question was, well, why is it not D? Why is it not 95%? We're so inclined to think about it being 95%, and I had to think about it for a second to kind of reason to myself why that is. So I think we're inclined to think 95% because we think of the 68, 95, 99.7 rule for normal models or normal distributions or the normal curve. But what we're not thinking about is what does this probability distribution look like. So I wanted to make sure we could have like a graphic to look at. And so what I did is I went ahead and entered the data on our calculator. So I'm just going to show you that real quick. So I went to Stat, went to Edit, and I entered in List 1 the probability, the number of cars 0 through 5. And then in List 2, that's the probability of having that number of cars for an American household. Now, if I wanted to find the expected value, I could hit Stat, Calc, 1 variable statistics, and use List 1 and List 2. And that would give me that expected value of 1.75. It would also help me find the standard deviation for the number of cars, which is 1.08. So the typical American household would vary by about 1.08 cars. So that helps us think about this question for 2 standard deviations within 2 standard deviations of the mean. So if we think about that, well, 2 standard deviations of the mean, well, that's going down to, so if I do this, I'm going to write this out so we can see it and then kind of think about it. So the average number of cars is 1.08. So if we think about going 2 standard deviations below the mean, well, that's minus 2 times, I'm sorry, I made a mistake there. The average number of cars is 1.75. And if we think about going 2 standard deviations below the mean, well, that's 1.75 minus 2 times 1.08, which is negative 0.41. Well, we should all think to ourselves and say, that's not reasonable. We can't have negative 0.41 cars. But we can have 0 cars. We can have 1 cars and 2 cars. If I think about 2 standard deviations above the mean, well, that would be plus 2 times 1.08, which is 3.91. Well, that's up to 3.91, but that's not including 4 cars. So this range, this 2 standard deviations within 2 standard deviations of the mean, that includes households that have 0 cars, 1 car, 2 car, up to 3 cars, but it doesn't go all the way to 4 cars because 2 standard deviations above is 3.91. So the reason why this answer here is C is because the probability of an American household within 2 standard deviations of the mean is a range of cars from negative 0.41 cars, which we can all agree is not possible, up to 3.91 cars. Well, that doesn't include 4 and 5. And 4 and 5, well, that's 0.05 and 0.02. So the folks that are excluded from this is 1 minus 0.07 or 700ths, which is why it's 0.93. So that should hopefully answer the question as to why it's within 2 standard deviations. We automatically kind of assume or think to the default of the normal curve, but that's not the case here. So hopefully this answers the question and clarifies any confusion about this topic. Thanks and have a great day.